Good afternoon, Internet. I am Matt Buyak, and in this video we'll be taking a look at the 20th problem from the Project Euler problem archive. So this problem asks us to find the sum of the digits of the number 100 factorial. And that might seem like quite a daunting challenge if not for the fact that we just spent the last two videos writing a big integer class to help us tackle this problem. Now, I'll note that our big integer class is far from complete, so you can expect many more installments in that series, but we do have enough that we should be able to tackle this problem at this time. So let's get into it. As usual, I'll copy our template directory to make our problem directory. But now I'm going to do something a little bit different, which is rather than writing our main.cpp from scratch, I'm going to copy the test that we made for our big integer class into our problem directory as our main.cpp. And I'll explain the reason for that in one moment. So if we go now and open our main.cpp, this is the code that we wrote to test our big integer class. And it happens to correspond to a solution to an earlier problem, problem number 16. If we go back to that problem, it's asking us to find the sum of the digits of the number 2 to the 1,000th. And so the similarity to our problem is probably quite obvious. But the idea is that you're repeatedly multiplying and then repeatedly dividing by 10 to get the digits. And that's exactly what we need to do for our problem, problem number 20. So the only difference here is that instead of multiplying by 2 1,000 times, we want to multiply by each of the natural numbers from 2 up to and including 100. And that should give us our answer. Now we will need to change our makefile to link our numtheory library. You'll recall that the way we have our environment set up, our tests all link libnumtheory by default, but our problem solutions do not, since many of them do not actually use libnumtheory. And that should be all we need. Let's go into our problem directory. Oh, obviously I have not, didn't actually build our library. Okay, and that gives us an answer, 648. So if we go back to the archive and open up our problem here, you'll see that that does match the solution. Now that was a pretty quick solution, but that's only because of all the work that we put in the last few videos and for problem 16 to build up that code. And so if you're curious about the inner workings of our big integer class or the theory that we used to develop that, I'd recommend going back and looking at those earlier videos. I'll put a link to those in the description. But with our solution in hand, it's time to move on to the next video, which will be problem number 21.